How does data travel from your browser to a remote server across a complex network? The Open Systems Interconnection Model, or OSI model, gives us a simple framework for understanding that entire journey. Computer networking involves applications, protocols, addressing, routing, physical transmission, and many other responsibilities. The OSI model separates those responsibilities into 7 layers so engineers can reason about each part independently. This layered approach also makes troubleshooting easier because a problem can often be narrowed down to one specific layer. For cybersecurity professionals, the OSI model is especially useful when analyzing packets, firewall rules, attacks, and network failures. Layer 7 is the application layer, where network services such as HTTP, DNS, and SMTP interact with applications. Layer 6 is the presentation layer, which deals with how information is represented, encoded, compressed, or encrypted. Layer 5 is the session layer, which manages communication sessions between applications. A useful mental model is that applications request services, presentation handles representation, and sessions manage conversations. For example, when you open a secure website, your browser generates application traffic that will eventually travel through the lower network layers. Layer 4 is the transport layer, where protocols such as TCP and UDP provide end-to-end transport services. TCP focuses on reliable ordered delivery, while UDP provides a lightweight connectionless transport mechanism. Layer 3 is the network layer, where IP addressing and routing determine how packets move between networks. Layer 2 is the data link layer, which handles local network delivery using technologies such as Ethernet and MAC addressing. Now imagine the client sending traffic through a router and firewall toward a server. The same communication can therefore be viewed differently depending on which OSI layer you are analyzing. Layer 1 is the physical layer, representing the actual transmission of bits through cables, radio signals, connectors, and physical interfaces. But before those bits are transmitted, data moves downward through the stack and each relevant layer adds information. Application data becomes transport information, then an IP packet, and finally a data link frame. This process is called encapsulation, and it allows each layer to add the information needed for its own responsibilities. At the destination, the receiving system reverses the process and removes the relevant information as the data moves upward. The OSI model is extremely useful for cybersecurity because security controls operate on different parts of network communication. A firewall may inspect ports and protocols, an intrusion detection system can inspect suspicious traffic, and a SIEM can correlate events from many systems. When analyzing a packet capture, you can map Ethernet information to Layer 2, IP information to Layer 3, TCP information to Layer 4, and HTTPS to the upper layers. This gives analysts a structured method for understanding packet captures, firewall logs, IDS alerts, and network failures. From top to bottom, the 7 layers are application, presentation, session, transport, network, data link, and physical. Do not just memorize the names, connect every layer to real protocols, devices, packet fields, and troubleshooting scenarios. Once you can map a network symptom or packet field to the correct layer, troubleshooting becomes far more systematic. Master the OSI model and you have one of the most useful foundations for networking, cybersecurity, and packet analysis.